Elaborating on a previous video in which we discussed the differences between form union and form assembly, this video focuses on the rotating machinery example of using form assembly. All rotating machinery simulations should use form assembly with the option to create identity pairs enabled to finalize the geometry. In the physics interface, flow continuity is defined to enable continuous flow across touching boundaries. Here we have opened the micromixer particle tracing model, and you can see the geometry has been finalized using form assembly with the option to create identity pairs enabled. This automatically generates pairs of any touching boundaries within our geometry. So these are the settings you should always use for any rotating machinery model. To avoid creating several identity pairs, we recommend organizing your model geometry before using the form assembly operation, meaning that you have united all of the geometry objects that form the stationary parts into one object, and united all geometry objects that form the rotating part into one object. Let's show the geometry labels now so we can better see the boundaries in the identity pair created. You can see that these boundaries distinguish the stationary domain from our rotating domain, which will be moving. This allows the mesh for the rotating domain, domain 2, to slide with respect to the stationary domain, domain 1. The mesh needs to be fine on these boundaries so that the fluid motion remains continuous and the flow field can be accurately resolved. If we go under the rotating machinery laminar flow interface, you'll see a flow continuity boundary condition is applied to the identity pair so that the flow field is continuous across the pair. The physics defined in the rotating machinery interface and the settings used for form assembly enable the motion of the domains and fluid flow across the rotating stationary interface.